Hey everyone, welcome to our sixth and final mini lecture on cannabinoids, chronic effects, part 2. Chronic use is associated with brain abnormalities. These studies are cross-sectional, so it's again the same problem that we've had with a couple other of these studies we've talked about, that you can't really infer cause. It's entirely possible that the number of brain abnormalities could have preceded use and then predisposed that individual towards use rather than the other way around, right? So we can't say that abnormalities were caused by use, nor can we say that the abnormalities caused use. So we can't infer directionality, we just know that they're associated. Another issue that is prevalent here is that these users often consume multiple substances. It's very rare to find someone who only uses one drug. So that could also be a factor here, and in fact, many of these studies don't control well for the use of other substances. So chronic use is associated with substantially impaired dopaminergic function in the striatum. This likely plays a role with some of the common syndromes we see, like disturbances in mood, motivation, cognition, and this dysregulation of the dopaminergic striatal system could contribute to cannabis use disorder. Another correlation that we see is that there is a relationship between early, heavy use of cannabinoids and an increased risk for the development of psychotic disorders later in life, such as schizophrenia. Again, this isn't saying that use will precipitate a schizophrenic or a psychotic break. It's just saying that those who go on later to develop schizophrenia are more likely to be heavy users early in life. We can't say which way that relationship influences the other. We don't know if one causes the other or if they're just merely associated. So another interesting factor here is that we know from rodent studies that adolescent use in rodents can lead to changes in glutamatergic, GABAergic, and dopaminergic systems. In fact, we see altered synaptic plasticity, dysregulated emotional and social behaviors, and impaired cognitive function. So speaking to that, some evidence from a study that your book highlights is pretty interesting. So what they did was they took a group of adolescent rats and over the course of 21 days injected them with a steadily increasing amount of a CB1 agonist CP55940, which is pictured in red on the top here, abbreviated as CP, or a vehicle solution as the control group. After 21 days of administration, they waited until the rats became adults, and then they did one of two things. So in this group, they harvested the rats' brain tissue and then actually measured the dendritic length of neurons in the prefrontal cortex. And what they show is that looking at the length of dendrites overall, that those that were treated with the CB1 agonist over 21 days show a significantly smaller length of the dendrites. This is carried mostly by a difference in the basal dendrites. So sort of in line with that, here tissue was extracted from animals that underwent the same treatment, and they basically tested the plasticity of the synapse between hippocampus and prefrontal cortex with an LTP, an artificial dish preparation LTP experiment, where they basically used high-frequency stimulation to artificially create long-term potentiation. If you're a little hazy on how LTP works, you can go back to our discussion of LTP and refresh yourself. But basically, it's just a model of synaptic plasticity and learning. What we see here is those animals that were treated with CP for 3 weeks show significantly smaller increases in excitability as a function of this high-frequency stimulation. So not only do we see actually decreased presence of dendrites in these prefrontal neurons, we see that these prefrontal neurons are actually impaired at making plastic changes that underlie like learning and connectivity changes. So while they do undergo LTP to some degree, they are much less excitable after the high-frequency stimulation, and this does not seem to be as robust. So let's talk about some other health effects of chronic use. Well, good news is you can't overdose and die on marijuana, so there's no reports of overdose death. However, there are other health risks. Smoking of marijuana can cause damage to your lungs. Like cigarettes, marijuana contains tar, carcinogens, carbon monoxide, etc., actually at levels in excess of tobacco cigarettes. So on a sort of smoke for smoke basis, marijuana is worse for you. That said, people typically don't smoke the same volume of marijuana that they do tobacco if they're daily users. So because of this, regular smoking is associated with various respiratory problems. There can also be effects on reproductive health, including menstrual cycle irregularities in women, and reduced circulating testosterone and deficit in sperm concentration, viability, and motility in men. So it is recommended that pregnant women or women that may become pregnant avoid marijuana use, as THC is highly lipophilic, meaning that it can pass easily through cell barriers, so it can pass through the placenta to the fetus pretty easily. So some ill effects that we see in birth and neonate is decreased body weight, increased startles and tremors, and decreased habituation to light, as well as altered sleep patterns assessed by EEG. Assessment of young children who were exposed to THC as an embryo show impaired cognitive development, an increase in aggression and inattention, and impaired memory function, as well as decreased verbal performance. By mid to late childhood, you see this cluster behaviors, externalizing behaviors, deficits in educational achievement, and an increase in depressive and behavioral problems. In adulthood, we see the development of altered visuospatial functioning. So there's not the great wealth of evidence that we have with some other drugs as to how this can affect us, but the best practice seems to be avoiding marijuana use during pregnancy. This is something to be wary of, as some sources will tout marijuana as a great remedy for nausea during pregnancy. That does not seem to be a wise way to deal with pregnancy nausea. I would avoid that. So the last thing we'll talk about is a word on synthetic cannabinoids. You may have heard of these as K2 or Spice were a few that were popular for some time. Use of synthetic cannabinoids has become more popular in recent years. This is because they either may be perceived as legal or may be actually legal, depending on whether or not DEA or FDA has caught up with regulation of these substances. These are somewhat similar to marijuana, but different in some important ways. Well, one, while this is distributed in the form of smokable plant matter, synthetic cannabinoids aren't plants. They are plant matter that has been sprayed with a synthetic a synthetic cannabinoid compound. Typically, these are full agonists that will produce a potent high. Because they're a full agonist, they're going to produce a different subjective experience than would THC, which is a partial agonist. These are metabolized by different pathways, meaning they're eliminated at a different rate, and thus pose a greater risk for toxic reactions. These produce a similar but more potent effect than cannabis. Because of this, there's a risk of needing emergency medical treatment is much greater with synthetic cannabinoids. Fatalities have occurred with some of these blends. Oftentimes, the synthetic chemical has been distributed unevenly, resulting in hotspots. So certain patches of the plant matter that have been sort of soaked with this synthetic cannabinoids can be more potent than others, leading to uneven distribution. You might get a bit that's really strong and have a really adverse effect. These typically don't contain CBD, and there is a theory that CBD may buffer against some psychotic reactions in THC. This might account for some of the more adverse reactions people have to synthetic cannabinoids. Generally speaking, people tend to not enjoy their experience on synthetic cannabinoids. Probably best avoided. Okay, that is it for our discussion of cannabinoids, and we will see you next time.